Why does time stop at light speed? You've probably heard this before. Einstein said, nothing can go faster than light. And somewhere along the way, someone told you that if you could travel at light speed, time would freeze. Most people think this is just extreme slow motion, like a cosmic pause button. That belief is not a little wrong, fundamentally wrong. Here's what actually happens. A photon leaves a star 8 billion light years away. It crosses galaxies. It threads through the void between superclusters. It survives for what we measure as 8 billion years. And for that photon, 0 time passes. Not almost 0, not a tiny fraction, literally 0. The moment it left that star and the moment it hits your eye are the same moment for the photon. The entire journey, 8 billion years of travel, is a single instant. No duration, no waiting, no experience of crossing anything. The universe aged 8 billion years. The photon aged nothing. And this isn't poetry. This is measured physics. This is what the equations demand. This is what experiments confirm. You think you understand speed. You think you understand time. But the relationship between them is stranger than any sci-fi movie ever showed you. It changes how you see motion, space, causality, what it even means to exist across time. Let me show you. Grab your phone. Seriously, turn on the flashlight. Point it at the wall across your room. Done. Here's the part nobody tells you. That light just traveled from your phone to the wall in about 10 nanoseconds. 10 billionth of a second. Before your finger even finished lifting off the button, photons had already smashed into the paint, bounced back, and entered your eyes. For you, that was instant. But here's the asymmetry that breaks everything. You experienced those 10 nanoseconds. Your heart pumped blood. Electrons moved in your brain. Time happened to you. For those photons, nothing. No time passed. The journey from your phone to the wall and back to your eye was not short. It was non-existent. Wait, how can something travel a distance without experiencing any time? This is where your intuition fails. You think speed is simple, distance divided by time. Faster means covering more ground in less time. And the fastest possible speed means covering ground in almost no time. Wrong. Light doesn't experience almost no time. Light experiences no time. And that difference isn't semantic. It's the whole game. Think about what just happened. You and the photon started at the same place, the phone. You both ended at the same place, your eye. But you aged 10 nanokens. The photon aged 0. You took a journey through time. The photon didn't. Same start, same end. Completely different experiences of reality. Do this right now. Turn off your flashlight. Then turn it on again. Watch the wall illuminate. That instant flash. That's 8 billion photons experiencing birth and death as the same event. No middle, no during, no passage. They're not moving fast through time. They're not moving through time at all. People say light is the quote-unquote fastest thing in the universe, but that's just a label. It hides what's actually happening. Light isn't winning a race through time. Light has exited the race entirely. And here's where it gets even stranger. This isn't something special about light. This is something fundamental about speed itself, about the relationship between space and time. Your phone flashlight just showed you a crack in reality. Now, let's look inside it. You've been lied to about speed, not maliciously, just incompletely. Since childhood, you learn speed means distance divided by time. Drive 60 miles in 1 hour. That's 60 miles per hour. Simple, but that's just a label. Here's what's actually happening underneath. You are always moving at exactly one speed, not through space, through spacetime. And that speed is the speed of light. Let me say that again. Right now, sitting still reading this, you are traveling at the speed of light. Sounds insane. Stay with me. Space and time aren't separate things. They're one fabric, space-time. Einstein showed us this. And through this fabric, you have a fixed budget, a single speed you must always travel, the speed of light. But here's the trick. That budget gets split between two directions, motion through space, motion through time. If you sit perfectly still, you spend zero budget on space. All of it goes to time. You rocket through time at maximum speed. Seconds tick. You age. Tuesday becomes Wednesday. Now start moving through space. Walk across the room. Some of your budget shifts from time to space. You're now spending a tiny fraction on spatial motion, which means slightly less flows through time. Your clock slows down. Brutal. Not noticeably. At walking speed, the difference is billionth of a second over a lifetime. But it's real. It's measured. It's not negotiable. The universe keeps strict books. Move faster. Drive a car. Fly in a plane. More budget shifts to space. Less flows through time. Your clock slows more. Still tiny, still undetectable without atomic clocks. But the accounting is merciless. Now here's the thing. What happens when you spend your entire budget on space? Nothing left for time? Zero. And what speed requires spending the entire spatial budget? The speed of light. This is why time stops at light speed. Not because of some magical property of photons, because of accounting. The budget is fixed. The books must balance. If you move at light speed through space, you have nothing left for time. Light doesn't negotiate. For a photon, the entire speed budget goes to spatial motion, every last drop. Nothing remains for temporal motion. No time passes, not slow time, zero time. Think about what just happened. Speed isn't a race against time. Speed is a trade-off with time. The faster you move through space, the slower you move through time. And light represents the extreme case, maximum space, zero time. This isn't preference, it's accounting. Hold that thought because this raises a terrifying question. How did anyone figure this out? Who looked at a beam of light and realized it doesn't experience duration? Who first understood that space and time share a budget? A 16-year-old kid daydreaming about chasing light. The year is 1895. A 16-year-old kid in Germany is bored in class. His name is Albert Einstein, and he's daydreaming about something strange. What would happen if I could ride alongside a beam of light? Simple question, catastrophic answer. See, Einstein knew about Maxwell's equations. James Clerk Maxwell had figured out that light was an electromagnetic wave, rippling electric and magnetic fields, leapfrogging through space. And Maxwell calculated the speed. Light always moves at about 186,000 miles per second. Always. The equations demanded it. But here's the part nobody tells you. Maxwell's equations didn't say light moves at that speed relative to something. They just said light moves at that speed, period. No reference frame, no conditions, just a naked constant. Wild. Young Einstein thought about this. If I could run alongside a light beam at light speed, what would I see? Logic says the light beam should appear frozen next to me, like two cars on a highway driving the same speed. You look over, the other car seems still. But Maxwell's equations refused to cooperate. They said light must always move at 186,000 meters per second. Even if you're chasing it at 185,999 meters per second, even if you're somehow moving at light speed yourself, light would still race away from you at full speed. Impossible, or so it seemed. Einstein sat with this contradiction for 10 years. 10 years. The frozen light beam versus the constant speed. Both couldn't be true unless speed wasn't what everyone thought it was. Unless time wasn't what everyone thought it was. In 1905, Einstein published his answer, special relativity. The speed of light is constant for all observers, not because of something magical about light, because space and time themselves adjust to make it so. The constant is enforced. If you chase a light beam, you don't see it slow down. Instead, your clock slows down. Your ruler shrinks. Space and time warp around you to preserve that constant. Light doesn't change for you. You change for light. Exactly. This is what that teenage daydream revealed. The universe doesn't care about your velocity. It doesn't care about your reference frame. The only thing it protects absolutely and without exception is the speed of light. Reality doesn't issue refunds. Time dilation, length contraction, the relativity of simultaneity. All of these bizarre effects exist for one reason, to keep light speed untouchable. And at light speed itself, the protection becomes total. Time stops completely because that's what's required to keep the constant constant. Light always wins, not because it's special, because it reveals the rules everyone else must follow. Now here's the thing. This sounds like philosophy, abstract thought experiments about chasing beams, but it's not. This is engineering. This is technology. This is measured in labs every single day. How do we know time actually slows down? What experiment proves this isn't just mathematical games? Imagine the simplest clock possible. 2 mirrors, one on the floor, one on the ceiling. A single photon bouncing between them. Every time the photon hits a mirror, the clock ticks. Tick, tick, tick. Simple. Now put this clock on a train. The train moves past you at tremendous speed. You're standing on the platform watching. Here's the part nobody tells you. From your perspective on the platform, that photon isn't bouncing straight up and down. The train is moving sideways. So the photon travels diagonally up and to the right, down and to the right, a zigzag path. Look, diagonal paths are longer than vertical paths, basic geometry. The photon now travels a longer distance between each tick. But remember the rule. Light speed is constant. The photon can't speed up to cover the extra distance. The constant is enforced. So what happens? The ticks take longer, more distance, same speed, more time between ticks. From your platform, the train's clock runs slow. Beautiful. Not an illusion, not a trick of perception. The clock genuinely ticks fewer times. Less time actually passes on that train than on your platform. This is where your intuition fails. You might say the train passenger sees your clock running slow too, and you'd be right. Both perspectives are valid. Both are real. Neither is the true time. There is no universal clock. The universe keeps strict books, but different observers get different receipts. Now watch what this implies. The faster the train moves, the more diagonal the light path becomes. The longer the distance, the slower the clock. And at light speed, the path becomes perfectly horizontal, infinite distance between ticks. The clock stops completely, not slow, stopped. Time ceases. So far, we've learned speed is a trade-off between space and time. The speed of light is protected absolutely, and a simple bouncing photon proves time itself must bend to preserve that constant. But thought experiments aren't enough. Where's the real-world proof? It's in your pocket. Your phone knows where you are within 3 meters. Think about that. A device in your pocket pinpointing your location on a spinning planet hurtling through space at 67,000 miles per hour, accurate to the width of a car. How? Satellites, 31 of them orbiting 12,500 miles above your head. Each one carrying an atomic clock, each clock accurate to 1/1000th of a second. Your phone listens to these satellites, compares their signals, calculates the time differences, triangulates your position. Beautiful. But here's the part nobody tells you. Those satellites are moving at 8,700 miles an hour. And according to special relativity, moving clocks run slow. The satellite clocks lose about 7 microseconds per day compared to clocks on Earth. 7 microseconds. Tiny. Except light travels 186,000 miles per second. In 7 microseconds, light covers over a mile. Your GPS would drift by miles every single day. Useless. Wait, there's another effect. Those satellites are farther from Earth's gravity, and general relativity says clocks run faster in weaker gravity. This adds about 45 microseconds per day. 2 effects, opposite directions. They don't cancel. The net result? Satellite clocks run 38 microseconds faster every day than ground clocks. The universe keeps strict books. So engineers pre-program the satellites. They deliberately slow the clocks before launch. They build relativity into the hardware. This isn't philosophy, this is accounting. Do this right now. Open your Maps app. Watch it find your location. That blue dot appearing, that's relativistic physics. Einstein's equations running in real time. Your phone does time dilation math constantly. Every rideshare you've ordered, every delivery you've tracked, every direction search, all of it depends on the fact that time runs differently at different speeds and different gravitational strengths. Light speed being constant isn't theory, it's infrastructure. But here's where it gets even stranger. What about particles that shouldn't exist? Particles that should die before reaching Earth, yet somehow arrive by the billions. That's not engineering, that's cosmic proof. Every second, particles rain down from space, cosmic rays, protons screaming across the universe at nearly light speed. They slam into our atmosphere 50 miles up, and when they hit nitrogen molecules, they shatter into debris. One piece of debris, the muon. A muon is like a heavy electron, unstable, radioactive, and absurdly short-lived. Average lifespan, 2.2 microseconds. That's 0.000022 seconds. Then it decays. Gone. Now, here's the thing. In 2.2 microseconds, even traveling at nearly light speed, a muon can only cover about half a mile, maybe less. But muons are born 50 miles up. Simple math. They should die long before reaching the ground. The atmosphere should absorb them all. We should detect almost nothing at sea level. Wrong. We detect thousands every minute. Every square meter of Earth gets bombarded constantly. When it's lucky right now, muons are passing through your body. Impossible unless time dilation is real. Those muons travel at 99.95% light speed. At that velocity, time slows dramatically. Their internal clocks crawl. From our perspective, we see them living longer, much longer, long enough to survive the 50 mi journey. From the muon's perspective, it still lives 2.2 microseconds. But the distance contracts, the atmosphere squishes, 50 miles becomes less than half a mile. Same result, different explanation, both valid. The constant is enforced. Quiet. This isn't a laboratory trick. This isn't engineered technology. This is nature screaming the truth at us. Billions of particles per day, proving that time bends, that speed warps duration, that light speed changes everything. Muons shouldn't reach you, but they do. The universe doesn't care about your expectations. So far, we've learned the light clock proves time must slow. GPS proves we engineer around it daily. And muons prove nature obeys the same rules at cosmic scales. 3 proofs, 0 exceptions. But we still haven't answered the deepest question. Why? Why does moving through space steal from time? What is actually happening to light that makes duration vanish? The answer will ruin you. Here's the part that breaks everything. Light doesn't experience time stopping. Light doesn't experience anything. Wait, we've been saying time stops at light speed, and mathematically that's true. The equations give zero, the clocks freeze, duration vanishes. But that framing hides something deeper. For something to experience time stopping, it must first experience. There must be a before and after, a sense of waiting, a frozen moment that feels frozen. Light has none of that. For a photon, emission and absorption are the same event, not connected by time, not separated by waiting, the same instant. Think about what just happened. That photon from your flashlight, from its perspective, it didn't travel to the wall and back. It was created and destroyed simultaneously. The journey didn't take 0 seconds. The journey didn't exist. There was no journey. Dangerous. This isn't about time slowing until it stops. This is about the entire concept of duration becoming meaningless. People say time freezes for light, but that's just a label. It implies light sits in some frozen moment, experiencing eternal stillness. Wrong. Light doesn't sit anywhere. Light has no moment to sit in. The very framework of before and after dissolves. Let me say that again. You live in time. Seconds feel like something. One moment causes the next. Your entire existence is duration experiencing itself. Light exists outside that framework entirely, not frozen in time, absent from time. Here's the deep truth. It's not that light is special. It's that we are massive objects, slow objects. We're the ones trapped in time. We're the ones forced to experience duration. Light is free. The universe keeps strict books, and light's receipt says 0, not small, not approaching 0, null. The category doesn't apply. This isn't physics being weird. This is physics showing you the edge of existence itself, the boundary where time means something and where it becomes a human illusion. Your flashlight reveals that boundary every single day. Turn on your phone flashlight one more time. Do this right now. Watch those photons leave, hit the wall, return to your eyes. You just witnessed something impossible. Billions of particles experiencing no time, no journey, no existence between moments. Birth and death as one event, repeated endlessly across your room. You aged reading this sentence. They aged nothing. Simple. Every light bulb, every star, every screen you've ever watched, all of it flooding you with particles that have never experienced a single moment. The universe keeps strict books, and you just learned how to read them. Speed trades with time. Light spends everything on speed. Duration vanishes, not as metaphor, as physics, as measurable, engineered, cosmic reality. The next time you see light, any light, remember this. You're watching messengers from outside of time, carrying information across billions of years, while experiencing none of them. Ancient photons in the Big Bang hitting satellites right now. Zero age, infinite journey. Done. Here's your question to sit with. If light experiences no time, does it experience anything at all? Is a photon an event rather than a thing? And if existence requires duration, does light actually exist? Leave your answer below. I'll see you in the next.